The objective of this lesson is I can find the surface area of cylinders and prisms. So as an opening, try these first two problems, so pause the video and try it. Now that you've tried them, let's go ahead and do the volume of this first one. Volume of a sphere is 4/3 pi times 12 squared, 12 cubed, r cubed. And so if you put in 12 into this equation and use your calculator, you'll get 3,619.1 cubic centimeters. Now, let's try looking at the cone next, and in doing a cone, I want to do both the volume and the slant height. So let's start with the volume. Volume is 1/3 times the base times the height. The base of this is a circle, so we're going to insert the 12 into our radius. So we have pi times 12 squared for the area of the base, and then the height of this is equal to 4. If we were to simplify that, we would get 603.2, and there's no units on this, so we leave it alone. Now let's try finding the slant height. The slant height is the hypotenuse, in this case, of a right triangle with 12 and 4 as the legs. So we'll call that C, and set up our Pythagorean theorem as C squared equal to 12 squared plus 4 squared. Simplifying that, we get C squared equal to 160. We take the square root of both sides. Now in this case, instead of having the plus or minus, since it's the side of a triangle, we're going to just leave it as the positive. Square root of 160 is square root of 16 times the square root of 10. Square root of 16 we know is 4, so we get 4 square roots of 10 for this answer. So let's move on, and we're going to talk about surface area today. And surface area, we'll break it into two parts, lateral area and surface area. The lateral area is really the area around a figure, the sides of it all put together. So if you take the area of the faces of it without the bases, if we see the bases of them, take those away, just do the faces, that's the lateral surface area. So the area of the faces without the bases, whereas the surface area itself is where we take that lateral area and we add it to the bases, the top and the bottom. So we take the area of everything. Sometimes we'll call it surface area, sometimes we just say area of the figure, sometimes we'll say total area. So if you add that lateral area to the bases, you get your surface area. So those are two ideas that you should know, and so probably a good idea to write those two down. So let me scroll up so you can see those. Let's talk about what happens with a cylinder though. Let me illustrate that for you with a soup can. So to illustrate the surface area of a cylinder, I picked my favorite soup, a can of clam chowder. And if you look at this cylinder, you have to look at the surface area. The top is a circle, the bottom is a circle, so we have two circles that we'd find the surface area of those two. And then we'd add it to the lateral surface area, which if you think about it is the label of this soup can. If you take this label and unwrap it, what we get is a rectangle. So we have to find the area of this rectangle, and this area of the rectangle is found by taking the height of the cylinder is the height of the rectangle, and then the length of this rectangle, if you look at it, is the circumference of this circle. So I take one of the top or bottom circles, take the circumference of it, and you get the length of the rectangle of the label. So as we saw, when we unwrapped the label of the soup can, we got a rectangle. So if you unwrap a cylinder, you get the lateral area to be a rectangle, whereas in this case, the top and bottom are cylinders, or excuse me, of a cylinder are circles. So the area of the bases are just 2 times pi r squared, because it's two circles, and a circle's pi r squared. Whereas the lateral area is the height, which is the height of the cylinder, times the circumference of the soup can or the cylinder, because that's what happens when you unwrap that label, is you get the circumference. And circumference is 2 pi r, or we could list that as pi times diameter also. That's another way to list it. So our total surface area is the lateral area, the the label part of the cylinder, to RH pi plus 2 circles, 2 times pi r squared, because that's the top and the bottom. So that's a formula we should know. So probably write that down and be able to use it when we're asked to find the surface area of a cylinder. So this surface area of a cylinder formula is one that we'll use quite a bit. Now, let's do prism. The prism I have here has a hexagon on the top and the bottom, which is a complicated figure, kind of like this pentagon. It has pentagon as the parallel bases, but notice all the lateral faces are rectangles. Also the same thing with this triangle on the bases for this prism, but all the faces are rectangles. Same thing if we have a box or a rectangular prism. You've got the bases being rectangles, but also the faces are. So if the hexagons are the bases, the area of the bases are going to be 1/2 times the apothem times the perimeter. Since there's 2 of them, we multiply it by 2. Whereas the other bases, the lateral faces, there's 6 of them since this is a hexagon. So we take 6 times base times height, which is the area of the rectangle. And so we get the lateral faces 6 times each of the rectangle areas. So the total surface area is if you take the area of the bases, the top and the bottom, and area of all the lateral faces, you add those all together, you get your surface area of a prism. Since our prisms can be different, like I showed you, this one's a hexagon, I showed you the other ones, you have to know that general idea that add the bases to the lateral faces, the lateral area, and you get your total surface area for a prism. All right, now we're going to take a look at a couple examples. Let's start off with a cylinder, and in both of these examples, I want us to find the volume, the lateral area, and also then the surface area. So we're going to start with volume on this one. To do the volume of this, volume of our cylinder is going to be base times height. Our base is a circle, so it's going to be pi times the radius squared, 4 squared, times the height, which is 8. And if we use our calculator, we get that to be about 402.1 cubic inches, because it's volume. Now to do the lateral area of this, lateral area is just the unwrapped part of the cylinder. And so that's going to be, in this case, the height, which is 8, times the circumference, which is pi times the diameter, or 2 radiuses, 2 times 4. And when we do that, we get a total lateral area of 64 pi. So next, we're going to do our surface area, and that's in square inches, because it's surface area. Let's do the total surface area. So surface area, in this case, we're going to take and we're going to add 2 of our bases, because we have 2 circles, so 2 times 4 squared pi, that's 2 of our bases, plus the lateral area, which is 64 pi. Add that all together. It simplifies to 96 pi. And if we were to do that on our calculator, we would get 301.6 square inches for our surface area. So that's a cylinder. Let's go ahead and try next a rectangular prism. The rectangular prism is going to be a box that we can pick where our bases are. We're going to select the top and the bottom being the bases. So on the volume here, volume of a rectangular prism is the base times the height. The base is dimensions of 5 by 5 square. The height is 12. So we multiply that out and we get 300 cubic inches. Now, when we do our lateral area for this one, we've got to decide what our bases are and what our lateral faces are. So I'm going to pick the bottom as a base and the top as a base. They're parallel sides. I could have picked either of the lateral sides because they're parallel also, but we'll just keep it simple. Keep it top and bottom as the bases. And then the lateral faces, to figure out the lateral area, those faces are around the outside of it. So notice that there are 4 of them because we have a square on the top and bottom. So the lateral area is going to equal 4 times those rectangles, which is 5 times 12 for this dimensions of those rectangles. And we've got 4 of them. We multiply that out, so we get 240 square inches for the lateral area. Now let's do the surface area. The surface area of this, we've got to take the bases of it, which are 2 squares, so 2 times the 5 times 5 for the square. And then we're going to do the lateral area, add that to it, and so we get the 240 added into that. And if we add that all up, we get 290 square inches. So the general idea is for finding surface area of cylinders and prisms is add the bases to the lateral faces